Hey engineers, and welcome to the first lesson in Unit 1.2. 1.1 was focused primarily on simple machines and gear ratios, sprockets and chains and pulleys. Now we're going to get into energy. We're going to be talking about how do we operate machines? Where do we get the energy from? Every single machine in this world that we use gets its energy from someplace. And how do we move energy from point A to point B? What are the different types of energy? So we're going to talk about that today in what we've called energy sources. We're going to talk about non-renewable energy, renewable energy, and inexhaustible energy. Different energies that they're similar because they allow us to do work, meaning that with energy, we're able to lift something a certain distance. That's energy. A calorie is a English form of energy. Sorry. The joule, those of you that have gone through physics, you've maybe heard of the term joule before. We talked about it in thermodynamics. It's the ability to do work, to physically lift an object a certain distance. So let's get started. The ability to do work. And work in a physics sense is taking some weight. You have some object that weighs something, and then you move it to a different height. That's what we call work. And it's also calculated by force times distance. So 5 pounds moving 2 feet, that's 10 foot-pounds of work. Or Newton meters if you want to go in the metric system. There's 3 different types. There's non-renewable, things that you can't renew. You maybe could think of something off the top of your head as being an energy source that you can't just easily replace. Renewable and inexhaustible. Inexhaustible means that there's enough to go around forever. The sun, first of all, is the original source of almost all energy. I mean, think about you got to school today in a vehicle, most likely, or you walked. The sun is the original energy source of that because the sun shone on plants. Maybe you walked to school. Maybe you ate plants for breakfast, or maybe you ate something that ate the plants. So in the end, the sun is where you're getting your energy to walk from. The gasoline in the vehicle that you use. Sun shone on plants many, many eons ago. Those plants decayed. They went underneath the ground, they rotted, they turned into oil, and we then use that petroleum in our vehicles, we burn it. So people say you're burning dinosaur bones. No, what you're burning is dead organic plant matter that has been decayed underground. So that's what petroleum actually is. So the sun was the original source there. Oh, Mr. Hare, I drive an electric car. Well, the sun warms the earth, and then that warming of the earth creates the wind that maybe turns turbines or hydroelectric plants. But the places where the sun is not the energy source, there are life forms that live near geothermal vents. They don't get to see the sun at all. So they're way, way, way down deep in the ocean or in caves where you never see the sun. You can live off the heat, the residual heat from when the earth formed, and they're getting their energy that way. But there are very few things that only get their energy not from the sun. Non-renewable. Some things that we just can't replace very easily. Fossil fuels like coal, oil, and natural gas. These are all different forms of dead plant matter that were in different phases, solid, liquid, gas, where we can burn. A lot of times we burn it and we harvest the heat to move something. Like in our vehicles, we burn gasoline and that thermal expansion pushes on a piston and that's what drives your wheels. Alternative energies are any fuel that's not identified as fossil fuel. So maybe like a methane digester, like if you're on a farm, like a lot of the cow farts, you can harvest and then burn that. And that's not a fossil fuel, but it's also an alternative. Or methanol, like if you go to get gasoline at the pump, you're getting you can use corn oil or soybean oil, put that in your gas tank and burn that. Another type is nuclear power, uranium. You're taking uranium, you're enriching it, meaning that you like pick out the little tiny pieces of uranium, you pack them together in a pellet, and it naturally gives off heat. So then you expose that to water, and that water will boil, and then you turn a turbine that way. So here's the steam generator. So you're using these uranium rods inside of here to create steam, and that steam goes around and turns a turbine, and then it comes back in. It's in a closed loop, so you're not letting that water out. Believe it or not, we can get energy from animals. We can move, there's lots of people around Platteville who still use animals to do a lot of their work. Can you name who they are? You're right. It's the Amish. They definitely use animals. Food. We eat food. That creates energy inside of our bodies. Biomass. A corn burner. Maybe you have a pellet stove, or maybe you have a fireplace at home. That's biomass, like things that were once living that you can then use for energy. Biofuels, and we talked about those before as alternative ethanol and methanols. Different places that we can get from the environment. So this will be what we call inexhaustible, things that will never run out. And hydroelectric, and believe it or not, hydroelectricity is sun driven. The sun makes water evaporate. The evaporated water goes to a cloud, and that cloud rains at some place at a higher elevation, and then it rolls back down and repeats the process. They call that the water cycle. Maybe you learned about that in middle school. But hydroelectric is inexhaustible as long as we have the sun. Again, the water goes through what they call a penstock. It turns this turbine around out the river, and we turn a generator, which creates power. Nuclear power plants do the exact same thing, but instead of using water that's at a higher elevation, they just boil steam, and the steam turns the turbine, which creates power. The tides. We can actually use the tides coming in and going out to push on things to create energy. That's inexhaustible. The tides are caused by the moon's gravitational attraction. And because the moon is around the Earth kind of like wobbles a little, just a small amount because of the moon orbiting. So the combination of the gravitational attraction and the wobbling, like taking a wine glass and you kind of swirl it around, that's what causes the tides. Geothermal, around Montana and specifically Iceland. If you're on top of anything like a magma below the surface that's kind of close to the surface, you can harvest that. And even here in Platteville, we can have geothermal. The ground, even though it doesn't get as warm as it will in Iceland or over Yosemite, the ground stays at a more stable, I think, 60 degrees. So in the wintertime, 60 degrees is warm, but in the summertime, 60 degrees is cold. So we can send like a fluid down into the ground in a tube, and that will either absorb heat in the summertime or it will give heat to in the wintertime. So you can use geothermal as something that will, quote unquote, never run out. The wind never runs out. If you ever drive to Darlington, and probably from the school, you look to the east and you can see those wind turbines. The wind is definitely driven by the sun. It heats up the earth, and then you have that convection, and that causes the winds. But again, as long as we have the sun, we're going to have the wind. Solar, same thing. As long as we have the sun, we're going to have power through what are called photovoltaic. This is actually a different type. So most things that you see, like these are solar panels on the International Space Station, or installing solar panels on the roof of your house. This is down near in California, it's called the Ivanpah Solar Electric Plant. These are big mirrors that all shine light to the top of this tower, which boils water, and that steam turns a turbine. Nope, and that's all I have for you today. The different types of resources. Remember, the inexhaustible, like anything sun-driven or earth-driven. The renewable things, like trees and food and animals, we can replace them within human lifetimes. And then lastly, non-renewable, fossil fuels, nuclear. Have a good day.